then the third session is going to be about inspection and troubleshooting. That's always a common problem and of interest out in the field. Over the last 30 years, I've done this. So a lot of people don't realize some things that they have to have for troubleshooting. So we'll go over that. And then the fourth session is a little bit on safety, most common hydraulic accidents and how to prevent those. Definitely don't want anybody getting hurt out there doing this, so we'll talk about that. When I do a video or a class or something like that, I want to make absolutely sure that there's an objective that I want people to walk away with. So in this particular session, components of hydraulic systems and fundamental elements that govern all of hydraulics. What I want you guys to walk away with on this is after completing this session, you should be able to field identify the 10 essential components used in heavy industrial hydraulic systems: reservoir, oil, prime mover, pump, relief valve, directional valve, linear actuator, which is a cylinder, a rotary actuator, which is a motor, and fluid conductors, like your tubes, hoses, fittings, things like that. And understand the fundamental elements that guide all of hydraulics. So if you walk away with understanding that pressure is force and flow is speed, you'll understand a lot more than most folks do when they're out there trying to troubleshoot hydraulic problems. All right, what we're going to do now is talk a little bit about different components in a standard hydraulic system, industrial hydraulic system. So the first one you have is the reservoir, right here. The second thing you have is the oil inside the reservoir, and you'll know how important that is by the time we get finished with all these sessions. Next is called the prime mover, which is usually an electric motor over here that actually drives the pump. Next thing we have is the coupling that's connecting the pump to the electric motor to allow the pump to turn. All right, the next thing is a hydraulic pump. And you'll notice that the pump is mounted below the oil level in the tank right here. And that's always the best way to do it because oil has weight to it and it keeps the pump primed whenever the pump is below the oil level. So that's always the preferred method on a pump. All right. So then you move up here to the safety relief valve. And what the safety relief valve does, it protects the system from overpressurization. Okay? So next thing we have is the filters. We got a filter back here. It's a little difficult to see. And then we have inside the tank here a strainer. And then as we go through this into the next couple of sessions, you'll understand what a strainer does and how they fail and things like that. Then the next thing we have is a directional valve. Here's directional valve here, solenoid operated. And then over here, you have a manual directional valve. You actually have to pull those with your hand. Next thing we have is a linear actuator that comes out in a straight line. And the next one is a rotary actuator that actually goes around and around. So in hydraulics, you only have two choices. You can go in and out or around and around, and that is it. So that's what makes that really simple for me to understand, and should make it simple for you guys to understand as well. All right, the last thing that we're going to talk about in the standard things that come in a hydraulic system is the fluid conductors, and that is your hoses and tubing and fittings and things like that. Of course, these components wouldn't do you any good unless they're actually hooked up and you have oil flowing through the system. Okay, so there's your inlet hose right there coming from your tank to your pump. Then you come out of your pump with this hose right here into this block here. Then you come with this hose right here into your directional valve. And here's your two work lines right here, your A and your B work line that go out to your hydraulic cylinder. And then here's your tank line that actually goes back through the filter to the tank. So that's the essential components of any hydraulic system in order for it to function, is those components right there. All right. The definition of hydraulics is a means of transmitting power by pushing on a confined fluid. as you can see by these hoses and the way all this stuff is hooked up right here, that fluid has to be confined to be able to do work. Whether it's pushing this cylinder out right here or rotating this hydraulic motor right here, that fluid is confined in all these hoses right here. So that's how it actually does work. There's actually three ways of transmitting power. One is mechanical, with gearboxes and chain and sprockets and things like that. The second one is electrical, with variable speed drives and things like that. And then the last one is hydraulics, or fluid power, and hydraulics or pneumatics, either one. So this is what we're going to talk about today, obviously, is hydraulics. All right, back in 1692, a gentleman named Blaise Pascal came up with the law that when you confine a fluid and compress it, it is equal and opposite in all directions. So that is the basis of all hydraulics. When you
He didn't mean to say compressed. You know that, right? Okay.
In hydraulics, what you do is you fill up the back of the cylinder right here with hydraulic fluid, and it's because oil is incompressible, it actually makes that piston move right there. Okay? So what we're going to do now is go over a couple of things that are essential in all hydraulics to understand. Is the first one is flow makes it go. Flow is speed. If your component is speeding up or slowing down, that is a result of the flow that's coming out of your pump. Okay? So I'm going to turn the system on right here, and what it's going to show you is this pump is pumping right here 1.8 gallons per minute. Okay? So that pump is pumping 1.8 gallons per minute, and I'm not moving anything out here like these hydraulic cylinders or the motor. I'm not doing any work, but the pump is still pumping fluid. All right, where is that fluid going? Okay, it's going over this relief valve right here and going back into the tank, okay, through this filter back here. All right, so the only way you see fluid right here is when I actually actuate this cylinder and make the cylinder go in and out. All right. So one thing I want to demonstrate to you is pumps don't pump pressure. Okay, that's one of the things that's a common thing that people don't really understand. They say my pump's not pumping enough pressure. So what I want to do is go over that real quickly and show you how that works. All right, you see on this gauge right here, I'm showing 400 psi. All right, the only reason I'm showing that 400 psi is because I have my bypass valve closed, and I'm forcing that oil right here across this spring inside this relief valve right here. Okay, so you'll see it if I move this relief valve in and out, the pressure goes up or down based on the resistance to that oil that I'm pushing across that orifice right there. All right, so what I'm going to do is prove to you pumps don't pump pressure. All right, I'm pumping 1.8 gallons per minute right here. So what I'm going to do is open this bypass valve and give it an easier path back to the tank. So what you'll see is, you see that pressure drop right there? That's because I'm giving it a free path back to the tank, and it's not having to go over this relief valve right here. Okay? So as I drop that, open that up more and more and more, you see the pressure drops down, and now I'm going to open it all the way up. So the only thing you see right here on the gauge is about 10 psi, and the reason you see that 10 psi is because it's taking that amount of back pressure to push that fluid through these fittings and through this block right here and make it go back through this filter into the tank. All right, so basically what I'm showing you is pumps don't pump pressure. Okay, the only way you see pressure in a hydraulic system is when it has a resistance. Okay, so I'm going to shut this and make the resistance come back, and you'll see that pressure go back up. Okay? So what I just demonstrated is pumps don't pump pressure. One of the fundamental things of all of hydraulics is flow is speed and pressure is force. So what we're going to do now is prove to you the flow speed. So what we're going to do is time this cylinder coming out at a certain rate of flow, and then we're going to cut that in half and show you that it slows it down. So that'll be pretty evident whenever you see that coming out. All right, so what we're going to do is see over here. You see the flow was right at about 1.8 gallons a minute, 1.6, something like that. So what I'm going to do is cut that down to about in half. So a little less than 1 gallon a minute, something like that. And then we're going to time this coming back out, and it should be about half. It may vary just a little bit because the oil is kind of cold, but we'll give it the old college try here. Alright, that's perfect. About 7 seconds, so it's about 4 seconds, so that's perfect. So the point was that when your flow drops, your speed drops as well. Okay? So it slows down. So when you're troubleshooting a hydraulic system, it's very important to understand the fact that flow is speed, and if you're not moving as fast as you're supposed to, you're losing flow somewhere. And that's the point of this video right here. Okay, what we're going to do now is talk about pressure, force, flow, and speed. So what we're going to do is prove that pressure is force by using this chart right here. If you go down the left-hand column under where it says bore diameter in inches, go down till you see a 4-inch bore, and then come across to the right until you get under where the pressure says 750 psi. Alright, if you look at that number, that's 9,425 pounds of force that a 4-inch bore cylinder can push at 750 psi. So what I'm going to do is prove pressure is force. So if you double the pressure to 1,500, then look over to the right under 1,500, and you see 18,851 pounds of force. So there you see that number doubled. So what that means is if you double the pressure, you double the force. Alright, what I want to use this chart for is in hydraulic systems, a lot of times people have problems with electric motors kicking out and nobody knows why. I'm going to do something to prove that to you here on this chart. Horsepower is calculated with gallons per minute times pressure divided by 1,500 psi, which is a constant. So what that means is if your gallons per minute increases or your pressure increases, your horsepower has to go up with it. So if you look at this chart right here, here's a kind of a neat chart to show you that, sort of demonstrate it. You go down the left-hand side of the chart until you find 10 gallons a minute, and then you come across to the right until you get under the 1,500 psi, and it shows you that you need 8.75 horsepower in order to run that system. Alright, if you double the pressure to 3,000 with the same 10 gallons a minute, you need 17.50 horsepower. So what that shows you, if you double your pressure at the same gallons a minute, you have to double your horsepower as well. Alright, so what we'll do is do the same thing with gallons per minute. So if you look over here on the left-hand side at 10 gallons a minute, and come over until it says 1,500 psi, you need 8.75 horsepower to run that system. Alright, if you double your gallons per minute and keep your pressure the same, you need 17.50 horsepower to run that system. So what I want you to get out of this piece right here is gallons per minute and pressure determine your horsepower requirements in a hydraulic system. Alright, what we want to prove with this is hydraulic horsepower either goes to work or it goes to wasted energy in the form of heat. And what I've got here is you look at the picture, I've got an example of that. There's a hydraulic cylinder working down in the bottom of a machine, and over to the right, you see I'm measuring the hose temperature at 134 degrees. All right, and then the one next to that, I'm measuring that 90 fitting right there, and it's 3 degrees hotter. So what that shows you is that when oil has to work unnecessarily, like when it's going across a 90 or it reduces down and it becomes turbulent, that is wasted energy in the form of heat, and that is called pressure drop.
Hey guys, Adam, I just wanted to play around with the little test unit for a second before we get ready to put this up. So I decided that I was going to run this little hydraulic motor right here. So we got the lines hooked to this one valve here, and we'll just watch this little motor run. And we can also control the speed also with the flow control valve. If you look right here, you'll see the shaft moving. Just use an angle direction down. That's on right. All right, we can also control the speed, flow control. We'll watch and slow it down. Yeah, I just wanted to play with that for a second, show another element of the training unit here. Paul's already done a good job of showing the little cylinders over here working, so I didn't want to bother with those. So anyway, just having a little fun with it.
All right, I hope this first session, that's the end of session 1, and hopefully that was beneficial to you guys. One of the things I really want you to walk away with and take away from this particular video is pressure is force and flow is speed. If you have something in your system that's slowing down, that is a result of you losing flow somewhere. So these flow meters right here, when we get into the troubleshooting part, you'll see how essential those items are, these items right here. All right, so again, that's a flow meter, that's a pressure gauge, and we went over all the other components. So what we're going to do in the next session is talk a little bit about component operation, how these things operate. Everybody thinks a reservoir is just a dome square thing, but actually it does a lot of other things besides just hold oil. So we'll talk about that in the next session. And not only that, as what you can expect to see when these items fail. When pumps fail, typically 99% of the time it's not the pump's fault when they fail. It's something else that's happening in the system that actually caused that pump to malfunction. So we'll talk a little bit about that in the next session. Thanks very much.
Again, there's a lot of analogies between electrical circuits and hydraulics. You don't necessarily agree that force is the same as pressure. You know that FAP and VAL are used as kind of terms that we use for describing what happens fundamentally in hydraulic circuits. But by the same token, pressure is the same thing as voltage in electrical circuits. It's a form of pressure. So when we talk about EMF or E or voltage, we're really talking about pressure, the same thing being in an electrical or in a hydraulic circuit.
Three grams of adhesive.
Hey guys, welcome back to the shop. My name is Paul, and we're continuing our hydraulic series here. The whole series is called Hydraulic System Inspection and Troubleshooting, and we've broken this down into 4 sessions. So this is session 2. So what we're going to be talking about in this session is component operation and how they fail. And I've got some failed components here that I'm going to show you while I'm doing this. And so hopefully it'll make it interesting rather than just, running my mouth the whole time. So the first thing we want to talk about is the hydraulic reservoir. A lot of people think that the hydraulic reservoir is just dumb and square and holds oil, but it really does several other things. I want to make sure that people understand that. The function of a hydraulic reservoir is it holds the system fluid supply, it transfers heat through the walls, it allows bubbles to rise to the top. When the oil comes back, it's very turbulent, and it's got air bubbles mixed in with it, so it allows the air bubbles to rise to the top. And when the oil comes back, it's got contamination mixed in with it, and it allows the contamination to fall to the bottom. So the reservoir does lots of things, so just making sure people understand that. All right, how they fail is leaks, obviously, is a safety hazard. Clogged breathers. There's a breather that's up here on top of the reservoir. And what I've got is one of these breathers actually taken apart so you can see the things that happen inside of that breather. This is just a piece of foam. So you'll see those breathers are basically garbage, okay? So they don't catch very much. The things that I need to protect this pump from are down in the 3 micron level, and this definitely isn't 3 microns, okay? So if you see one of these silver breathers on top of your system, it basically isn't doing very much, okay? So one of the things we do recommend is a heavy-duty breather, okay? So what this does, it catches particulates as well as moisture, and some popular brands are Eaton Vickers, and Descase is another popular brand that catches particles as well as moisture. So anyway, make sure you have a good breather, because that's where your #1 ingression point for all your foreign materials coming into your system is through that breather. And by the way, contamination is the #1 cause of failure in all hydraulics. So if you can protect your system from getting contamination in it, you'll be miles ahead, okay? Next thing we'll talk about is the hydraulic oil. Hydraulic oil is actually inside the tank, obviously. So hydraulic oil does lots of things. It lubricates your internal components. It acts as a sealant. And a lot of people don't realize that oil actually seals these different components right here. If you look inside this valve right here, you see these little cuts in these lands right here, okay? So this is your spool inside of a directional valve. This is your pressure port right here. This is your A and B work ports right here. And then out here is your return line back to the tank, okay? So as this valve shifts back and forth, it has to be lubricated, okay? So that oil lubricates that spool as it moves and also seals this P line from the A and the B line right here with these little small orifices right here, okay? So that oil acts as a sealant as well. So that's important to understand. All right, the other thing oil does is acts as an energy transfer device. Okay, so oil is incompressible. So whenever you fill up the back of the cylinder right here and it actually pushes out, that's because of the incompressibility of oil. Okay, so a couple of things how oil can fail is be too cold. You noticed this morning when we started this thing up, it was cold. So you see all that vacuum right there on that vacuum gauge? The reason you see all that vacuum is because the oil is cold right now, okay? It's not up to operating temperature. So you always have to have a vacuum gauge in this line right here on your pump inlet to make absolutely sure you're not cavitating your pump. Okay? All right, next thing we want to talk about is your prime mover, which is your electric motor right here. Okay? Your electric motor's job is to turn your pump the right RPM to make sure you've got the right amount of discharge gallons per minute through this right here. All right, you see I got 1.8 gallons per minute. That's because my motor is turning at 1800 RPMs and it's turning my pump at 1800 RPMs, and the displacement inside this pump right here is the right amount where I'll get 1.8 gallons per minute through this flow meter right here. Okay, so that's prime mover's job is to make sure the pump turns. Okay. So a couple of things, failure modes of your electric motor. Your bearings can go bad inside your electric motor, obviously. When you're in startup condition, you can turn the wrong rotation. It's supposed to turn right-hand rotation, and it can turn left-hand rotation if you wire it wrong. All right. Misalignment. If you misalign the shaft of this pump right here, you can pull air in through that shaft seal right there, and you can damage your pump. So misalignment is very important. Soft foot, obviously, back here on your electric motor. And then your RPM going too fast or too slow. That can affect your gallons per minute coming out of your pump. All right, that's your prime mover. Next thing we want to talk about is the pump. Pump is the heart of the system, and 99.9% of the times when your pump fails, it has nothing to do with your pump. It's something that happens in the system, like contamination or cavitation or aeration or things like that we're going to talk about in our troubleshooting and inspection part. So this is called a cartridge kit, and this has your vanes in it. Like inside this pump right here, you would have one of these cartridge kits, okay? And inside this cartridge kit, this little ring right here, this is your ring and your rotor with your vanes in it right here. And so what happens is that thing spins around and your vanes contact this ring right here, and that's how you pump fluid. You've got an increasing and decreasing part of this ring right here, so that's how you pump your fluid in and out of this pump. Okay, so how that thing fails, your pump, is when you cavitate it, you get these nice little divots right here, these little chatter marks inside your ring. So when you fail a hydraulic pump, take it apart next time and see what the ring looks like on your vane pump right here. Those little chatter marks right there says that I've got some cavitation problems. Okay? All right, on a piston pump, this is called your rotating group right here on your piston pump, and you see your nice little pretty shoes right there, your little brass shoes that spin around on the inside of your pump. All right, I don't know if you can see this, I know it's hard to see, but right there in the middle of this piston is how it gets lubricated, okay? And here's a larger version of that, so hopefully you can see that. That little tiny hole right there in the middle of this piston is how it lubricates itself as it spins around on that what's called a swash plate, okay? When you starve your pump for fluid, that oil doesn't come through that little hole right there, and you get what's called cavitation, okay? And as your pump cavitates, this is what happens to it. Those little pretty black shoes melt, okay? So as those brass shoes melt and disintegrate, obviously all that metal right there is going somewhere, and it goes out into your system and starts getting into your valves and actuators and your seals and all that sort of stuff. All right, so when those pieces come apart like that, it actually, this piston right here, the shoe came off and actually dug into this plate right here as it was spinning around on here, and that's the reason that it finally failed. Okay, so it's important to understand what cavitation, aeration, and those things do to your system. Very, very damaging to your system. Alright, let's hear what that sounds like. What we want to do is show what cavitation and aeration sound like in a hydraulic pump, so you'll know what to be listening for. And the way this little demonstration unit is designed is so I can show, this is lets air in right here, and this actually shuts my flow off right here from my pump, and you can hear what those things sound like. You gonna do that? Adam's going to demonstrate that. What he's going to do first of all is start shutting this. What he's going to do first of all is start shutting this valve off a little at a time. And what you're going to see is little vapor cavities start forming in this hose right here. And what I'm doing is starving the fluid into this pump, and the oil actually starts boiling. That's those little vapor cavities you're going to see right here. So I'm going to get Adam, if he doesn't mind, to shut that off. Alright, you hear that? See those vapor cavities right there? That's what cavitation sounds like. Alright? So that's kind of neat. Alright, so now what we're going to do is aerate this pump and show you what aeration looks like and sounds like. And he's going to open this valve right here and let some air in the system. Alright, you see my flow is dropping off right here. My flow is dropping off right here. And the reason my flow is dropping off is because, remember I told you, oil is incompressible. Alright, what I've done now is add air into my oil. And you see all this foamy stuff right here? Alright, that's because the oil is now mixed with air, and my oil has become compressible. So that's the reason my flow dropped off. Alright, this pump now is not pumping oil anymore, it's trying to pump air, so it just stops pumping. And you see your flow drop off right here. Alright, the next component we're going to talk about on the system here is your safety relief valve. What a safety relief valve does is protect your system from overpressurization. Okay, this pump right here is called a positive displacement pump, and it will pump up to whatever pressure this thing will go to until it finds the weakest link. If it's the electric motor, it'll kick the electric motor out. If it's a hose, it'll rupture the hose. I've seen actual bodies right here of your pump housing right here blow up. So if you don't have a safety relief valve in a hydraulic system and you get a clog somewhere, it's going to go, the pressure will go as high as it wants to, okay, until it finds the weakest link. All right, so some of the failure modes on a pressure relief valve is contamination. When it gets contamination in there, you have a spring inside there that moves back and forth, and it doesn't move very well whenever it gets contamination in it. Another one is heat. As your system heats up, these spools inside of here and even over here on your directional valve will start sticking. So if you got things sticking in your hydraulic system, that is because your oil is oxidized, and it'll start turning a dark color right there. You see this is a real light color, an amber color. All right, when it starts turning dark, that means you've got heat in your system, and that oil is oxidizing. And that actually tells your spools inside here to start sticking. Okay? The next one is any mechanical device. You have springs inside these mechanical devices like your relief valve that go back and forth every day. So with that mechanical motion, over some period of time, that is going to break. Okay? So a relief valve, over a period of time, as it opens and closes, and on your directional valve here, as it moves back and forth, those springs over a period of time are going to break. So that, just expect that. The biggest one, failure that I have with these relief valves right here are the wrong pressure range. All right, if I'm going to operate my hydraulic system at, say, 1500 psi, and I get a relief valve that goes from 0 to 800 psi, what's going to happen is every time you turn that system on, your fluid's going to dump over your relief valve, and nothing's ever going to happen out here. Okay? So very important to make sure your spring range is correct on your relief valve. All right, the next thing we're going to talk about is the filtration. Filtration is very important. Chevron did a study and determined that 75% of all hydraulic system failures are directly related to bad oil, dirty oil. So if you can add the right filters in the right places and get that dirt out of there, you'll be miles ahead. All right? You know, I mentioned earlier about your breather. That's all you have in these little silver breathers right here. There's this little foam, garbage. Okay? Use a nice breather. I'm not saying use Vickers, I'm just using this as an example. Use a nice breather that can take particulates out of your airborne system. How a filter works is your fluid comes into the filter and goes on the outside of the filter media and pushes it through the filter media and comes in through the middle of the filter and out through the discharge over here. Alright, in the top of this filter housing, you obviously can't see that here. We're going to pull a picture in to show you that, is you have a spring that's called a bypass spring. Okay? And as that filter media gets clogged up, that spring pushes open and your fluid starts going straight through your filter and nothing gets filtered. So it's very important to make sure you have a bypass indicator on your filter, which I have it on there, but it's very difficult to see because it's way up under there. Okay? The next component we talked about is your directional valve. Okay? Your directional valve. Here's a nice little demonstration of how a directional valve works. You energize the coil on either end of this spool, and it has a push pin that pushes the spool over to the left or to the right. And as I mentioned earlier, here's your pressure port, here's your A port, your B port, and then your tank ports are on either end right here. Okay? Oh, sorry, right here and here. Alright, so when I energize this valve, it opens up my P port to my B port and my tank port to my A port right here, and allows the cylinder to come in and out. Alright, when I de-energize it, these big springs, like this, push the valve back to the center position. Alright, when I energize it in the other direction, I've now connected my P port here to my other work port right here, and my other work port here to the tank line. Okay? So that's how a directional valve works as it shifts back and forth. One of the neat things, how these things fail, is the actual definition of a directional valve is it starts, stops, and controls the direction of flow in your hydraulic system. So one of the biggest things talking about failure modes of these is your oxidized oil I talked about earlier, getting in these orifices right here and keeping this spool from being lubricated, and it gets stuck. And people start trying to beat on them and all kind of things, and it will not move unless you clean it and get it back the way it's supposed to be and change your oil. Okay? One of the things that I often hear when I go in and out of facilities is it's mechanical. No, it's electrical. It's mechanical. No, it's electrical. All right, only these directional valves right here, this right here is called a manual override. Okay? So at 2 o'clock in the morning, if whatever your actuator isn't moving, you can get a push pin or a little Allen wrench or something and come over here and push that right there in, and it'll manually shift this valve. So if your actuator goes out or your motor starts turning, then that tells you got an electrical problem. Okay? So that's one of the biggest things I run into out there at 2 o'clock in the morning. All right, the next thing we want to talk about is the actuator. These actuators, again, you have a linear that goes in a straight line, and you have a rotary that goes around and around. Okay? If your cylinder is not coming out fast enough, that means you don't have enough flow. Alright, we got 1.8 gallons per minute. We determined a while ago with our little stopwatch that cylinder should come out in 4 seconds. Okay? So if your cylinder starts coming out slower than that, that means you're losing flow somewhere in your system. And you have to go figure out where that is. And the only way to do that is with these flow meters. Okay? We'll talk about that more when we get to the troubleshooting and inspection part. But you have to have these devices in your system to be able to figure out what's going on in any hydraulic system. Alright, same thing with your hydraulic motor. If your motor is turning and it slows down, then you are losing flow in your system somewhere. And again, this pump, you see that it's pumping 1.8 gallons per minute. Alright, so if that drops down to 1.0 gallons per minute, that means something's wrong with my pump. Okay? So it's very important to understand where your flow is going in a hydraulic system. Alright, the next one, we talked a little bit about that just a second ago, my rotary actuator. Again, you go in and out or around and around in a hydraulic system. So if my hydraulic motor slows down or speeds up, that is a function of flow. Okay, so that's very important to understand that. Then the last one is your fluid conductors, which is your hoses and tubing and fittings and things like that to connect all of these devices together to allow the fluid to move in and out of those properly. Okay, so some of the failure modes that you can experience is overpressurization of your system. I mentioned that earlier, and these things actually blowing up or exploding, these hoses right here. Another one is using a phosphate ester, which is a fire-resistant fluid in your system, and you don't change your hoses to a Viton type hose, and your actual hoses will melt. Your O-rings inside of all these components right here will melt. So if you get this weird gray substance in your filters, that means that you're using the wrong kind of oil and it's melting your O-rings inside of all these devices, your sealing devices. Okay? Another one is not being supported properly. You have to have pipe and hose clamps and supports in your hydraulic system, or these things will start rubbing together like this, and you don't want these things rubbing together because they'll start fracturing. And that's the number one cause of safety problems in hydraulics is slips, trips, and falls, and oil injection. So if you have a hose that's rubbing on another one and it starts spraying right here, and you walk up there and touch it with your finger, you'll get injected with oil. And we'll talk about that in the safety part. Well, that's the end of session 2. I appreciate you guys sticking with me through that, and I hope you learned something. And next session is inspection and troubleshooting. And what we're going to do in the next session is show you how to set up inspection routes on your hydraulic systems. And we're also going to teach you how to do some troubleshooting tips and tricks for troubleshooting. And what you're going to find out is these are all one and the same. When you start doing inspections and start troubleshooting, it's important to have these devices right here in your system, or you cannot do that properly. Okay? So look forward to seeing you in session 3.
I'll send you session 3 via email. I think it's pretty good. You learned something, I think, out of those couple of videos that I showed you. Exam schedule for next week. Take a look at your syllabus. Anticipate anything that we covered prior to the previous exam will be on it. It won't be all FAA test questions. Some of the info that you received this evening probably will be on it as well. Okay, any questions, anything that you want to discuss? Questions?
When you say previous information, are you talking about from day 1? Or?
No, just from the last exam.
Okay.
Yeah. Okay. Anything at all? Okay. You got a couple of written assignments to do. Don't neglect them. Don't wait till the last minute. All right, I'll see you out in the lab in just a few.